WatchGuard partners, and thank you for joining us today for the October Tech Talk on digital certificates. I'm Linda Schnell, one of your field marketing contacts, and with us today is Terrence Davis, Sales Engineer Extraordinaire out of the South Central region, who will be covering the digital certificates and certificate authority presentation with some live demo. Now, before we get started, let's cover the following housekeeping items. You are all in listen-only mode, so please use that question box throughout the session to ask questions. This webinar is being recorded and will be available in the partner portal in the coming days. And as always, don't forget to take that survey at the end. At this time, I'd like to pass it over to Terrence. Terrence, take us away.
All right, thanks, Linda. And thank you, everybody, for joining us. I look forward to spending a little bit of time with you today, as always. And what I want to talk about is certificates and the certificate authority, but very specifically on how we use them within the XTM. So one of the things that I like to do, and let me just give you a little bit of background, is anytime that I do a tech talk, I like to basically use that as a way for a learning tool on my own. So I always pick a subject that I don't know very much about. And that gives me two things. It gives me the ability to learn that subject, but it also gives me a view of how a partner or perhaps a customer of yours might be looking at something for the first time. So what I hope to do is spend a little bit of time giving you a little bit of insight on how the digital certificates are used within the XTM product itself. And the live demo, I will cover probably 2 or 3 different scenarios and some of the things that I found and some of the gotchas that you might run into. So what I really want to do is, and let me preface this before I even get started, is I want to show you what I've learned, but in that process I also understood from my own self that I didn't know a lot about the PKI, the public key interchange. So what I want to do before we even get started with the live demo is show you a little bit about the PKI and how that works, because I think it's very useful in understanding how that process even moves forward. All right. So with that, just making sure everything comes up with digital certificates, and let me explain to you just real quickly what that means. So what is a digital certificate? What it really comes down to is it's a way for someone to verify that you are who you say you are, but it also verifies that whatever you sent has not been tampered with. And this is really accomplished by encrypting and decrypting the message using a public and private key. But to understand how that really works, like I said, I want to give you a little bit of an idea of how I understand the PKI process to work. Now, I may not be totally right on with this, but it helps me to understand how PKI works, and I think it'll help you understand if you're not familiar with that process yourself. So think about this from the Dummies Guide to PKI. So basically what I want to share with you is I've got user A, and for my process I'm going to use Alice as the name because it's a lot easier for me to say Alice than it is for user A and user B. And I've got another user called Bob, and that's going to be user B. And basically what it comes down to is Alice needs to get a copy of user or Bob's public key, okay, so that Alice can send Bob an encrypted message using public key cryptography. So now this could be a connection from a user. Of course, it could be a connection from a user to a server. It could actually be a connection from server to server. But in this case, or for this demonstration, I'm just going to say that this is a user trying to get a hold of another user, or at least try to communicate with another user using PKI. And in that process, as far as Bob sending his public key out to Alice, Alice needs to give Bob a copy of a public key as well. And this is really where digital certificates come into play. Digital certificates are used as a way to tie a user's identity to that public key. And it's real important because if I accept somebody's public key and I accept it as being valid, if somebody else gets in the mix and actually interchanges that public key with their own, I may be talking to the wrong party. And I'll give you a little bit of that information here in just a minute. So really what happens is the digital certificate is signed by either the person, and that's called a self-signed certificate, or an authority that has created it. And in this example, if Bob trusts that authority, basically he's saying to himself that I trust what Alice sent me, and so I understand it is actually from her, then he'll accept that public key and they can continue to communicate. And really the important aspect of public key cryptography is that Alice and Bob must be convinced that they have the right public key for each other. All right, so now what happens if you place somebody else in the mix? Let's call her Eve, and she's a would-be hacker. She could have substituted her, her own public key for Bob's if she were able to intercept Bob's, and then place her public key in the mix, and basically send it on its way over to Alice. And if she did that, she could actually be reading everything that Bob was sending, or everything that Alice was sending to Bob by decrypting it. And if she did that on the flip side, if she actually took Alice's key and intercepted it and sent it back to Bob, she would be listening in on the entire communication. And and that can happen quite a bit. So this is actually where we have the certificate authority come into play. Now, one thing before I get started on that is Alice and Bob could actually meet in person, or they could call each other to verify that they have the right public keys, but, that's not really practical, especially if you think that, from a standpoint of Alice, maybe Bob is a server, or from Bob's standpoint, maybe Alice is the server. And what he's trying to do is communicate with the server to maybe put in his credit card information. If Alice has a web store and she's trying to secure all that information through the credit card, and Bob tries to call Alice, how does he know? I mean, Alice could be in California and Bob could be in South Carolina. Bob doesn't know if he's actually talking to Alice. He could be talking to anybody. And it could be that the phone conversation was intercepted by Eve as well. So that's where we have the CA come into play. So what the CA server does is it actually takes a copy of Bob's public key and accepts that public key, and then takes that information and verifies that Bob's public key came from Bob. It goes through a little bit of a process. I don't know if anybody online has ever went through the process of getting an SSL certificate or a digital certificate from any of the CAs that are well-known, VeriSign, GoDaddy, RSA, a couple others. But basically through that process, they will look at either the information that was sent and verify it through a couple emails, or they will actually go back to, in my case, the authority of the domain itself. So since I was the authority over my domain, they sent me an email to verify that I was accepting or asking for a public key for the domain that I was the authority of. That way they can take that public key and send that certificate to Alice along with Bob's public key. And now Alice can be pretty sure that she's got Bob's public key. The only thing that she has to verify is that she has the right public key for the CA server. In this process, and this will go a couple different ways, it basically takes Eve out of being able to impersonate Bob by giving Alice her public key. So really the only recourse that Eve has at this point is to pretend that she is the CA. And if she can pull this off, of course, she could listen to everybody's communication, not just Bob and Alice, but anybody else that she could get in front of. But really what happens at this standpoint is Alice just needs to verify that she really has the public key from the CA, and this should be pretty easy because Alice can create a list of CAs that she trusts. So this kind of goes into a chain of trust, and really the way to understand that chain of trust is to just look at this picture real quick. You can have somebody that is responsible or creates a high-level CA, and then they can have multiple CAs underneath. For instance, Bob could have a small ISP that issued him a certificate, and Alice could be on the other end on a small ISP that issued her certificate. As long as those certificates or the certificate authorities that issued those certificates were underlying or under the hierarchy of a higher NCA that was maybe protected by the government, you could be pretty sure that if you accepted a public key or or I'm sorry, a digital certificate from one of those lower-end CAs, it's protected by the higher-end CA and thus protected by the government, and you can be pretty sure that the public key that you're receiving is also from who it says. So basically, the certificate chain is just a hierarchy of CAs, one lower than the other, and this will come into a little bit more understanding for those that have not dealt with this before when we get into the live demonstration and when I actually go out and get a certificate from a certificate authority, and you can see as I start to push that certificate into, or start to import that certificate, it actually gets, I have to go through a chain in order to do the import. So let's real quickly just go over how some of these certificates are actually utilized by the XTM devices. First and foremost, you can use it for encryption of management session data. And really, when you think about it, when you look at that management session data, you know, this is to encrypt connection from the WSM to the management server. If you've ever set up a WatchGuard management server, and then you made a connection to it, you've probably noticed that you have to accept a couple of certificates in order to complete this connection. One of those certificates is a little bit higher end certificate, but it's part of that chain. The system at that point will allow you to make connection. And what it does is it stores those certificates on that device. So if you, again, connect to the WatchGuard management server from a different device that has not already stored those digital certificates, you're going to be asked again to accept them. So that's one way, encryption of the management session data. That can help you feel secure that when you're talking to the management server, trying to pull a config down from the Firebox, or setting up branch office VPNs, doing the drag and drop VPN, any kind of communications that's going in between your device, the management server, and also the Fireboxes is all going to be encrypted. You can also use certificates for the phase 1 connection between branch office VPNs, and you can also use them for mobile user VPN connections. Now, you know, most of us, if you've been with WatchGuard for very long, been a partner with WatchGuard for very long, in most cases when you're setting up a branch office VPN or you're setting up a mobile user VPN connection, you're really probably just going to use pre-shared keys, because it's pretty simple. As long as you're the one that knows the pre-shared key and you're working on both ends, you've got it made. However, if you happen to be working with another corporation and they're not willing to accept just the use of a pre-shared key, you may have to at some point in time import certificates to be able to use for branch office VPN connections. Thirdly, you can also install a certificate which can be re-signed for use with the HTTPS proxy. And this allows the HTTPS inspection of content by exchanging certificates and reusing certificates to complete the HTTPS communication. And I'll cover a little bit of that in just a few minutes. Next, you can use it for web server protection. So if you have a server behind your Firebox and you want to protect that server through HTTPS connections, you can also use digital certificates, exchanging the public key and the private key of the user, much like I just described with Alice and Bob if one of those were to be a web store. And lastly, we use it for authentication or authenticated connections. So in this case, it could be authenticated connection to the Firebox using single sign-on if you wanted to do it that way, or if you were trying to force authentication. If any one of you have ever used the IP address :4100 as a way to authenticate users or force authentication of users, you could actually, anytime you did that and you didn't have a digital certificate that was either signed and imported to your PC, or a digital certificate that had a high-level CA that was understood by your web browser, you would always get those little, annoying messages saying the certificate is invalid, and everybody hates those. So we're going to go through the process of trying to get rid of that message first, and then after that I'm going to go through talking about how we can use it to encrypt and decrypt the information for the HTTPS proxy content inspection. All right, so let's go to the live demo. Let me cancel out of my PowerPoint. And so the first thing we need to do is we need to get on a Firebox. I'm going to connect to the Firebox that I happen to be behind right now. And once I get connected, first thing I'm going to do is actually bring up the Firebox System Manager. The Firebox System Manager has the CA basically for that Firebox itself. And you can see here on the front screen it talks about what certificates it has available on it currently. Most of those certificates, or actually all of these certificates, are installed by default. And if we actually go into the CA, you can get a better understanding of what they're being used for. Let me expand this out a little bit. For the web client, and this will be the client if you were to use a web client with HTTPS inspection going out, you could use this for the web client just to verify that you were exchanging a public key with somebody that had the true identity. You also see here that this is for the proxy server. So the HTTPS proxy server is going to protect that deep application inspection. But what I'm going to do right now is I'm going to show you the process that I had to go through in order to protect, basically protect the connections coming to the Firebox if you were just logging into the Firebox, if you wanted to use the web UI, if you wanted to use the :4100 and you didn't want to have that annoying message. This is the process that you have to do in order to download and install a third-party key. What I did is I got my third-party key from GoDaddy, and I'm going to connect to that in just a minute. But the first thing that you have to do is you have to create a request. And you have a couple choices here. When you create the request, you're going to either create the request for a proxy authority, that is for that deep application inspection that I mentioned earlier, or you're going to create it for protecting a server behind the HTTPS proxy. And that would be an HTTPS proxy server and not an HTTPS proxy client, as in here, or for everything else. And in this case, for the first part, I want to go ahead and install it for everybody else. So what I have to do is I have to pick basically what I want the name to be. I always use my company name, and this is a fictitious company that I've created a long time ago. And I only fill out the pieces that are required. Everything else is not really required. It's not going to help you in any way. You can fill it out to just give you more information through that certificate, but it's not used by the certificate itself. My company name, my fictitious company is, and actually I say it's a fictitious company. I actually did own a vineyard at one point in time. And then the country is U.S. So that's all I really need. Again, I could fill out all this other information if I wanted to. Of course, I could say this is a South Central Lab, and maybe this is Hideaway, Texas, if I wanted all that to be filled out. But again, like I said, that's not actually used for the certificate. The DNS name, you can actually fill this in with an alternate DNS name. So you would have www.shfind.com, and in that case, you could also use it for your internal domain. For instance, if I wanted to use the server name, I could use zeus.shfind.local, which is my internal domain. In this case, I'm just going to use the IP because it seems to work okay. And since I'm protecting the inside and the outside has already been protected by the use of shfind.com, I'm just going to type in the IP address of the Firebox. And normally everything by default is good there. I say next, and of course I got to give it the configuration passphrase in order to create this request. And once the request is created, I have it right here. Now what I have to do with this is I want to copy it, and once I say finish, and you can import now, but a lot of times what you're going to do is you're going to create a request, you're going to send it out. Sometimes it comes, it takes 2 or 3 days, so you can go ahead and finish here because you have the ability to import it any time. And what I mean by that is you can see here that now I have this pending request. And this pending request is going to look at the key that I bring back to them based on the information that I have in that request that I created. All right. With that request, what I have to do now is I have to get on GoDaddy, which is where I bought my public key. So I log into GoDaddy. The reason I went with GoDaddy, we'll look at that. Again, the reason I went with GoDaddy is they have some SSL certificates, and they're relatively cheap. You can get 3 years for about $74, which is actually very, very reasonable. Now, the nice thing about GoDaddy as well that I found out is you can go back there and you can rekey whatever you purchased as many times as you want to. They don't have a limit on it, and it gives you the ability if you want to change it, if you want to try something else, you can go in and look at all those. You can rekey it as many times as you want to, and I'm going to rekey it a couple times here so you'll get the idea of how that actually works. So I go to Manage Certificate, and once that certificate comes up, there it is. All right. Now that I've actually clicked on the certificate and I have the certificate available to me, there's a lot of things that I can do here. For right now, I'm going to rekey it because I just created that request. I need to use that request to rekey the certificate. Remember, I did a copy, so all I have to do now is paste that information in for my request and hit the rekey button. So what this is going to do is it's going to basically revoke the key that I actually had available, but it doesn't really revoke it. It actually just rekeys it for my use again. And now that it's rekeyed, I have to go out and download it so I can import it into my Firebox. One of the things that you'll notice is you have a lot of different options here. The one that I always use for everything that I rekey is the other button. I'll download that certificate, and then I'll save it to my desktop. And you can see here now I've got it on my desktop right here. So what I'm going to do is I'm going to extract it. And there's the bundle that I extracted. So what I need to do now is I need to go through the process of importing the certificate so that this is no longer pending. It's actually signed, but I need it to be signed by a CA. And here's where we get back into that picture. That if you can go back to one of those last slides where I had that hierarchy, I actually need to create the entire hierarchy inside this import. So what I'm going to do is I'm going to open up the certificate that they sent to me, and this was sent by or downloaded by GoDaddy. And if you look at the certificate path, you can see here, here's the chain that I need. The first step is I have to install this one first. So I'm going to actually view that certificate, look at the details, and I'm going to copy it to a file. So why am I going to copy that to a file? Well, first and foremost, I need it to be separate from everything else. I need to import that certificate first before the next one will import properly. So what I'm going to do is I'm going to change it to base 64 because that's the certificate type that we use on the Firebox. I'm going to click Next, and I'm going to name this GoDaddy 1. And what it's going to do is it's going to create a GoDaddy 1 CER certificate right here that I can import into this import feature. So what I do is import, and this was for the IPsec web service. I'm going to load from that file, and what I'll do is go to the desktop shvine where that GD1 cert is, and I say import. It already remembers my passphrase, and it gets imported into the certificate. You can see here, there's the GoDaddy Class 2 Certificate Authority with all of the information necessary. Now that I have that one in place, I can go back and get the next certificate in that chain. You have to import them like that in order for them to recognize the chain of the hierarchy. So I'm going to view this certificate, copy it to file. I'm going to call it GD2. Say next. And actually, while I'm here, in order to make this a little bit shorter for the process for time constraints, I'm going to actually look at SH-Fine and go ahead and get the details for it, which is the last certificate I need in order to import it and get rid of that pending state and actually have it signed. And then I'll copy it to file as well, base 64, and I'm going to call it GD3. So it's the third one that I've got to do. And so now that I have them all there, you can see here that now that I've got the first one started, I'll just go back and copy the second one in place. And as soon as that's done, you'll see here that here's that second one with all the information for the second part with the information for GoDaddy. And now that that one's in place, I can import that last one. Of course, we still have a pending right here. I can import that last certificate. And that last certificate is that GD3 that I created. And now I no longer have a pending state, and I've imported a valid certificate. Now that I've done that, I've got basically that certificate in place. I really don't need these anymore. So I'll just get rid of that. And you can see here that when you look at the front end, you have all this information. When you go to the front panel, here's all the certificate information that you have available to you now that you've imported all those. And you can get all the information about what the certificates actually do. Excuse me. All right. One of the other things that I've noticed is, we have a tendency to want to get rid of those annoying messages that pop up when we use the HTTPS deep packet inspection. So let me go through, walking through kind of a self-signed for that, showing you how you might process that self-signed certificate. In order to do that, you're going to open up a policy first because you're going to have to create this and set this up so that you can start to process this through that HTTP proxy. So what I'm going to do is I'm going to actually disable this policy, and I'm going to create a proxy policy for HTTPS. And I'm going to go to the properties and make sure that I go ahead and enable deep packet inspection. And I'm going to use the auth or the auth settings that I have on my HTTP client, which is right here. Now, this bypass list, basically you would want to use that if you had something internally, such as the SSL 100 device, which was using port 443, or maybe you had port 443 set up for the WatchGuard appliance to use SSL, or maybe even OWA. So whatever you have set up, you want to go ahead and list those IP addresses in order to bypass this deep application inspection so that it doesn't look at it through the proxy itself. So anytime you go through some SSL communications, there's no reason to run it through the proxy if you run it through SSL, or even for OWA for that matter, especially because it's already internal and you already know that it's valid and doesn't come from somebody that you don't know because you're the one controlling it. So in this case, I want to put in 10.192.168.1, and that is the firewall itself. And I'm going to say OK. And OK. And close. Now that I have that policy in place, what I have to do is I want to basically create a self-signed certificate. Now what I have to do on creating a self-signed certificate is I actually have to go out and export one first. So in this process, actually pretty easy again, you're going to go to the Firebox System Manager, open up the certificates again. Now that you have those open, you're going to want to export the one that you're using for the certificate or for the proxy server. Now you can see here that I don't have one in place. I actually deleted it earlier. I could create one, or I could put one in place. What I'm going to do first and foremost is I'm going to actually create one from a third-party certificate, and then I have the ability to import and export that. So in this case, let me go ahead and pull up the certificate authority again. What I want to do is import a certificate, and it's going to be the HTTPS, the proxy authority for deep application inspection. And what I really have to do is create the certificate first. Sorry about that. So I'm going to create the request. And what I'm going to do here for basically the company name is Stonehill Vineyard. And I'm not going to fill out the rest. I'm going to accept it on one, which is fine. Right here, you can see that I'm putting the same address in. You could actually put your domain name in. And if this was a WatchGuard certificate that you had, you could put multiple domain names in. I don't have a WatchGuard certificate, so it's not going to allow me to put multiple subdomains for shfind.com. I can only choose one, and that's going to be the www, like right here. So I'm going to create that request. And now that I have that request, I'm going to go back through that whole process that we just went through. Let me go through it a little bit faster this time for the sake of time. And I want to rekey this certificate. And now that I've got it rekeyed, this is for a different rekey. This is a different request. So now that I've got it rekeyed, I want to download that. Select Other. Download it. Save it. And I'm going to close this. Now here's the nice thing. Since I've already downloaded basically the information for GoDaddy, I don't really have to do that again because it's already in there, and that's exactly where I went and got that certificate. So when I extract this, I don't have to go through that process again because I've already got the two higher level or the upper hierarchy of the certificate already in place. So all I have to do is open up this certificate that was created by GoDaddy and just get the details for this one piece. I don't have to go through and do like I did before where I have to create that hierarchy and put that in place. I'm going to call it shfind. You can see it's exported here. So I go back in and I do the import from a file. And there's my shfind that I created. I say import, and I'm done. You can see here now that I do have an HTTPS proxy authority certificate that's available to me. Now this is a signed certificate authority, but since I got rid of my self-signed certificate, I want to show you that by default you will have an HTTPS proxy authority. Now it's not going to be like this one. It's going to be self-signed. And a self-signed certificate is going to look a lot like this where it has the serial number of the product in place. But it is going to say HTTPS proxy authority. And this is the certificate that you have to use when you're importing or exporting certificates in order to push them out to systems so that when they use that self-signed certificate and you're using deep application inspection, you're not going to get that annoying certificate not valid. So in this case, I'm going to go ahead and export it just like I would a self-signed certificate. I have the ability to call it whatever I want, so I'm going to say XTM, and I'm going to actually put it out here on my desktop. So I save it, and this is the self-signed certificate right there, or imaginary, the self-signed certificate that I created. And now that it's exported, what I have to do is I need to import it to devices. You can use SMS. You can use some kind of a process to email it to everybody if you wanted to in your organization. SMS or something to do with Microsoft is the easiest way to export it to many people. But that's only if it's self-signed. You wouldn't have to do that if you went out and actually did what I just did and created a third-party cert from GoDaddy or somebody else, it would accept that, and when it looked at the hierarchy, it would say that it's accepted, and you wouldn't have to worry about exporting it out. But just for the sake of knowing how to use that self-signed certificate, I'm going to go ahead and take this exported certificate, and now I'm going to import it into my PC. Now, one of the things that you got to understand is it really depends on the OS of your PC of how you do the import of this certificate. In this case, I'm running XP, but we have a fairly thorough knowledge base that will go through the export of this for anybody that's using maybe, I don't know, Mozilla or Firefox, Mozilla Firefox, or maybe Max or something like that. So you might want to go out on the internet afterwards if you're using anything other than Internet Explorer on an XP system, or if you're maybe using Internet Explorer on Vista system, it'll be a little bit different than this as well. So what I need to do at this point is I actually have to import that file, and this is the file that you would probably send out, right? So in order to do that, I got to go to Run, type in MMC, go to the root console, and go ahead and add in the snap-in for the root console. And we're going to look at just the certificates, and this is going to be a computer account certificate. It's not going to be an end-user certificate. So you click Finish, you click Close, you click OK, and now you can see here that I have this full snap-in available to me, and it's going to show me all of these certificates that I already have on this system. What I want to do is I want to make sure that I put this exported file in my Trusted Root Certificate Authority on my system itself. So the process of that is actually expanding it, go to Certificates, and you can see here, here's all the ones that are already available to you. But you go to Import, Next, and then you just have to browse to the file. And since mine's in a PEM format, I have to open it up for all file types. There's my self-signed CA certificate right there. I click Next and Finish, and it's now imported into my system. And the way you'll know that is if you come down through the system, you'll see that there it is, Fireware XTFs, and there's the one that has the account information in it for the serial number and everything else. That's a self-signed certificate. Now basically what I've covered is really some of the easier sections of certificates and certificates authorities. We have a certificate authority on the WSM, and I could spend probably 2 or 3 hours talking about our certificate authority, different ways of creating requests. You can use OpenSSL, you can use Microsoft Server. There's a lot of different ways that you can create requests and import and export certificates. I wanted to focus primarily on the certificates that you would have available for you on the Firebox and how to use the Firebox System Manager to actually import, export, and pull in third-party certificates. Basically what I've done is I've showed you the way that you're going to get rid of that annoying message if you go to use the web UI on a Firebox, if you set that up. Also, if you tried to authenticate inbound to your PC, you wouldn't get that annoying message anymore. You've got that certificate, that third-party certificate that basically says this is accepted by almost all browsers. And also, if you wanted to use deep packet inspection without your end users getting that warning, you could do it two different ways. One, the first way, which is you could actually take that third-party certificate and import it into a proxy authority. Then that way it would pass through and nobody would get that information or that warning from the certificate. The other way is what I just showed you, which is the self-signed certificate. The only difference in that is if you do create a self-signed certificate, you have to push that self-signed certificate out to everybody that's in your network. So hopefully this gives you kind of an idea of some of the intermediate things or the beginner things that you can do with certificates, and perhaps maybe on some Tech Talk later on we might get into the process of showing you some of the in-depth ways that we can use certificates on the Firebox. So I guess now I turn it back over to Linda, and if we have any questions, I'll try to answer what I can.
Terrific. At this time, I'd like to remind all of our partners to please use the question box. Now, we did queue up one question here.
Okay.
And I'm going to try and decipher it just a little bit. So it's a question on the wildcard certificate.
Yes.
If we have a cluster of XCSs with multiple MX and A records and want to set up an SSL certificate for the multiple A records, is this a good example of where we would use a wildcard certificate?
Yeah, absolutely you could, but you have to remember that when you use the wildcard certificate, you're going to actually use subdomains. So in this case, instead of a subdomain like www or support.example.com or www.example.com or ssl.example.com, you're going to actually have to create your DNS records for each one of those XCSs. So in this case, for multiple XCSs, you could have xcs1.example.com, xcs2.example.com, and that gives you a little bit of leeway in changing their IP addresses if necessary, because it's all based on the domain itself. The domain's going to check, make sure that the certificate is valid regardless of what the IP address of the XCS device is.
Terrific. That's all the questions we had. And Terrence, any final words for our partners?
Yeah, basically digital certificates are a way to really protect your customers. And, when I got into them, there's a lot of us out here that probably don't use them as much as we should. And really, as far as the way we should be using them now, with GoDaddy, and I use GoDaddy as an example because they're extremely reasonable as far as digital certificates. But if you're spending $70, $75 for 3 years, we should start using digital certificates for our customers a lot more, at least pushing them in that direction if they plan on using any kind of deep packet inspection, or if they want to get rid of those annoying messages. Of course, we can always use self-signed certificates, and there's nothing wrong with that. But third-party certificates, the price of them have come down to the point now where we ought to start looking at those. So that's all I got to say.
Great. We have upcoming webinars this month. Tomorrow, October 14th, is our quarterly sales and marketing refresh. On October 25th is sales training for Fireware XTAM 11.4. And on November 10th, we have the next Tech Talk, which is WatchGuard tools for managed security services. We look forward to seeing you on a future webinar, and thanks so much, Terrence, and to our partners. Take care.